MetaCities in brief. Cyprus application area. The Cypriot cluster will leverage knowledge and infrastructure available in smart city projects in Cyprus, mainly Nicosia and Paphos, and b. the Nicosia platform developed by CYENS. This will allow for the upscaling of the existing digital platform with new 4D functionalities to help better integrate smart city data. An interactive 4D map can be used to plan utilities management such as public transport, garbage, piping, cabling, buildings, and heating, or to connect the many parts of a factory that can be inspected and steered in detail. By overlaying physical modeling, the 4D map can be used to forecast expected and predicted actions and behaviors of the environment and of other users, follow the history, and to check and control the function of parts. Use Case 1 Urban planning. The EU focus is on modeling and tracking of the interplay between natural and societal systems. For example, how policies and economics modeling predict human behavior's impact on the environment, how explicit or implicit incentives and social norms interact with the environment's evolution and exploitation, how real-time environmental awareness and intelligence can improve behavior towards more sustainability, or how the decisions based on changes in the environment in turn affect the state of the natural environment. Use Case 1 Urban planning. The project will develop an integrated platform for analytic and prediction of large-scale GIS, local demographics and other geocritical dataset collected from various sources. Develop an integration process for combining all the terrestrial datasets, remote sensing data, SAR imaging and using advanced machine learning and deep learning techniques to perform geospatial object detection. Focus on extracting meaningful information like building stock analysis, noise maps, real estate prices, green cover, urbanization, urban sprawl and other critical markers for estimating the trend of urban growth. Use Case 2 Smart parking. Everyday people suffer to find a parking slot, especially in crowdsourced cities. Driving around the city doing circles for a slot is a daily issue. Parking is a $25 billion industry that's seen little innovation in decades. Furthermore, urban traffic is the cause of 40% of CO2 emissions, 70% from emissions of other pollutants arising from road transport, and over 30% of traffic in a city is caused by drivers searching for a parking spot. Use Case 2 Smart parking. This use case aims to solve these problems by significantly reducing parking time, thus playing a major role in creating a better, less stressful and environment-friendly urban environment. An interactive 4D map can be used to visualize different parking metrics, like occupation, busy hours, types of cars, frequency of reuse, etc., and can be combined with AI/ML tools for all types of prediction. The Cypriot pilot deals with smart urban planning. It will make use of interactive and immersive technologies to visualize and understand smart city data. To achieve that, there must be an effective management of the various dimensions, spatial and temporal, of the information. This will be achieved using an interactive 4D map. By overlaying physical modeling, the 4D map can be used to forecast expected and predicted actions and behaviors of the environment and of other users, follow the history, and to check and control the function of solutions created for different problems in the city. Human and AI operators can explore the rich data and simultaneously modify it to manage and schedule activities, effectuating changes and tasks through actuators and controllers in the network. This optimized management of flows will contribute to the transformation of cities towards sustainable models. The relevant methodological approach and the resulting action plan are depicted in figure below. They are oriented towards the way in which the MetaCities conceptual model will be applied in order to achieve the objectives of the project. R&I strategies must be linked with goals that serve a greater purpose and bring prosperity and benefits to society, e.g. the Sustainable Development Goals by UN. It is therefore important that the proposed strategies and the accompanied measures have some kind of guarantee that will be successful before their actual implementation. Smart cities, and the proposed evolution thereof to the digital twin and metaverse worlds, can provide the necessary tools and information that a strategy needs to make sure that it meets its goal. Long-term R&I vision and strategy, CYENS. First, this task will articulate the local R&I strategies. R&I strategies must be linked with goals that serve a greater purpose and bring prosperity and benefits to the society, e.g. the Sustainable Development Goals by UN. Then, it will jointly define the long-term R&I strategies, recommendations and implementation guidelines on digital twins and metaverse for smart cities and smart regions in Southeast Europe. Further technical details on recommendations and implementation guidelines will be elaborated in WP3. This joint effort will contribute towards convergence of the localized strategic plans in the long term, thus facilitating stronger cross-border cooperation and knowledge exchanges, and more efficient joint implementation undertakings. This will serve regional and national authorities to specify their long-term R&I strategies, direct investments, and guide the involved stakeholders to implement them. Long-term R&I vision and strategy, CYENS. The governmental organizations and agencies, MPAT, UCM, BUR, RWG, DMRID, from all the 3 cluster counties GR-CYBG, in collaboration with all consortium partners, they will co-design the R&I strategies and policies and co-create recommendations and implementation guidelines in alignment with national and the EU Smart Specialization Strategies, RIS3, that will support regional and national authorities to specify their long-term R&I strategies, direct investments, and guide the involved stakeholders to implement them. Recommendations will be proposed in the form of architectural blueprints and best practices for the necessary ICT infrastructures and platforms, along with their capabilities and KPIs that are required in order to meet the requirements and specifications placed upon them by the digital twins and metaverses. Long-term R&I vision and strategy, CYENS. First, this task will articulate the local R&I strategies and to define the necessary steps for fusing them into one joint strategy. R&I strategies must be linked with goals that serve a greater purpose and bring prosperity and benefits to the society, e.g. the Sustainable Development Goals by UN. Then this task will jointly define the long-term R&I strategies, recommendations and implementation guidelines on digital twins and metaverse for smart cities and smart regions in Southeast Europe. Technological, economic, cultural and social factors will be considered. Recommendations will be proposed in the form of architectural blueprints and best practices for the necessary ICT infrastructures and platforms, along with their capabilities and KPIs that are required in order to meet the requirements and specifications placed upon them by the digital twins and metaverses. This will serve regional and national authorities to specify their long-term R&I strategies, direct investments, and guide the involved stakeholders to implement them. The governmental organizations and agencies, MPAT, UCM, BUR, RWG, DMRID, from all the 3 cluster counties GR-CYBG, in collaboration with all consortium partners, they will co-design the R&I strategies and policies and co-create recommendations and implementation guidelines in alignment with national and the EU Smart Specialization Strategies, RIS3, that will support regional and national authorities to specify their long-term R&I strategies, direct investments, and guide the involved stakeholders to implement them. This joint effort will contribute towards convergence of the localized strategic plans in the long term, thus facilitating stronger cross-border cooperation and knowledge exchanges, and more efficient joint implementation undertakings. In this slide, we demonstrate the concept of MetaCities. Starting from the physical world, representing the actual city or region, MetaCities will propose a series of system blueprints and recommendations that can be used to successfully build the digital twins and metaverses. The DT is the digitization of every element that makes up the physical world, accurately emulating every process and behavior that characterizes it. As DTs are directly and in real time, interconnected and interacting with the physical city, exchanging processing data and making decisions, they can execute actions on the city's operations that may affect its daily life. This direct bond between physical and digital worlds is also exploited by the cities to enter the metaverse era. The first set of challenges raised by MetaCities' conceptual model relates to the choice of the ICT infrastructures that should be deployed, interconnected, and operated across the city, ensuring that they have the capabilities and resources to realize our model. They make up the end-to-end path that will connect the DT with the physical world, transport and process big data. From this perspective, serious challenges are raised that need to be addressed. To decide on the combination of the technologies that make up the end-to-end system architecture tailored to the city needs and capabilities, to adopt the appropriate information models for the data and APIs for accessing and sharing it across different domains, and to decide on the business model for the operation of smart city ICT infrastructures. MetaCities' conceptual model also introduces the second innovative technical dimension that facilitates the goal of creating, maintaining, and managing DTs and metaverses for future smart cities. This is the role of the ODTF, a reference software architecture that describes the digital model, function and interactions of its physical counterparts. Not only does it categorize the common functions that a digital twin should implement, but also classifies the data intelligent model a digital twin should build. ODTF provides an integrated object framework for developers consisting of DT and metaverse building blocks that can be used to build domain-specific digital twins and metaverses enabled by the ICT infrastructures of the smart city. Specifically, by deploying various sensors in key locations such as streets, buildings, etc., and combining with other sources of information, we can fully perceive the running state of the community in real time. Using the ICT infrastructures to communicate the generated data to big data and artificial intelligence algorithms, we can feed the developed DTs to visualize the reality of the city. This is a powerful mechanism that will allow us to predict trends, run various scenarios, and eventually optimize cities' performance by making its systems run more efficiently. Through this dynamic and powerful bidirectional communication link, DTs mirror the vibrant, complex and evolving nature of its physical urban counterpart, which makes them an ideal sandbox for policy experimentation. That is, DTs also helps us to compile the city's strategy, the policies to put in place, drive the investments, and recognize digital skills and competencies in various key sectors of the smart cities. The technical challenges here are to identify the kind of building blocks that are necessary, the technologies for their development, the process for their integration in order to instantiate DT, how to link them with the physical world. The technical aspects introduced by the MetaCities conceptual model are tightly coupled with non-technical ones, such as business and societal. To this end, DTs with the essential knowledge they consolidate are instrumental in evaluating these decisions and the effect that they will have on the city and its society before they are implemented. For instance, the adoption by the city or region authorities of one of the 17 Sustainable Development Goals, SDGs, that was set up in 2015 by the United Nations General Assembly, presupposes a series of technical options, trade agreements, consultations, pilots which ensure the desired result. From this perspective, becoming a smart or a metaverse city is not a goal in and of itself, but the means to help cities better serve the people who live and work in them. It is therefore imperative that the methodology identifies and efficiently coordinates the core elements, technical and non-technical, required to build smart cities of the future underpinned by DTs and metaverse that serve the goals of the city. Furthermore, it should also provide the designs and the guidelines to create them. Taking these two as inputs, MetaCities will design pilots and demonstrators drawn from specific smart city sectors, namely, smart mobility, GR, smart buildings and energy efficiency, BG, and smart urban planning, CY, jointly contributed by the 3C clusters, CY, BG, GR. Specific use cases have been outlined in the context of each sector that will drive the design of the pilots and demonstrators.